Okay, thank you very much. Hello, everyone. So today's talk is about hacking cookies in modern web applications and browsers. Technical talk. Let me briefly introduce myself, what's my background, what's my experience. I'm founder and CEO at Silesia Security Lab. What we basically do is pen testing and specialized security training. My background is very much related to bug hunting. I was fortunate enough to find bugs in Google, Yahoo, Mozilla, Microsoft, Twitter, in many cases award-winning bugs. Now I'm sharing my bug hunting experience. I have a training, hacking web applications, case studies of winning bugs in Google, Yahoo, Mozilla, and more. I just shared this knowledge at different conferences around the world, including DeepSec. In the last 2 days, we had another edition for the second time in a row here in Vienna at DeepSec. And here's my email and Twitter if you want to ask me anything, if you want to follow my research work, and so on and so forth. So what's the motivation to bring this talk here? First of all, cookies store sensitive data. So sensitive data like session ID, cross-site request forgery token, and so on and so forth. So naturally, as they store sensitive data, they are interesting from attacker's point of view. Really good motivation. Another motivation. Many people are focused on multi-factor authentication, and this is very good because we know that we need strong authentication, two-factor or three-factor authentication. This is perfectly fine. But many people tend to forget when I do pen testing or security auditing is that they focus very much on very strong authentication, but they forget the simple rule that security is as strong as the weakest point. We need to keep in mind that once the user is authenticated, then the security is dependent on the security of user's account is dependent on security of processing authentication cookie, right? User authenticates, and then when the user is successfully authenticated, the only piece of data that is used by the web server to recognize the user is session ID that is stored in a cookie. So if we have, after successful strong authentication, any kind of weakness in processing of authentication cookie, then we may end up with very severe problems, right? So we need to keep it in mind, and here is the good, very good example. People very often forget about this. Yeah, we have three-factor authentication, so everything is fine. No, definitely not. I will show you more examples. So I will show you examples. So this is yet another good motivation. Another one is that security evaluators, many people here, we do a security evaluation of products. And what I've noticed is that many people underestimate cookie-related problems. That's why it was yet another good motivation for me to bring this talk. People claim very often that, for example, cookie via XSS via a cookie, maybe it's interesting, but from practical point of view, you need access to the machine of the victim, so it is only exploitable locally, so it's not interesting, right? So the risk is low. So people very often think that cookie-related problems or exploitation of cookie-related vulnerabilities is related to local exploitation. It is absolutely not true, and I will show you examples. And now another perspective. So far, I have been talking about web application security-related problems, but we process cookies, so naturally we have web application and we have a browser, and it turns out that we have also problems related to secure cookie processing on browser level. This is very nice from attacker's point of view because now the attacker is much more powerful. Attacker can chain vulnerabilities in the web application together with vulnerabilities in browser to have something very powerful at the end. So this is yet another perspective. So I will show you a couple of problems in modern browsers with secure cookie processing. And what are the consequences of insecure cookie processing? Because, well, we are interested in consequences. Many bad consequences like authorization bypass, user impersonation, XSS, SQL injection, and so on and so forth. So really, really bad consequences can happen as a result of insecure cookie processing. So now I believe I convinced you that this subject is interesting and worth discussing. So what's the agenda? 3 perspectives of insecure cookie processing will be discussed. Web application, I already mentioned this. Browser, I already mentioned it. And yet another one, RFC 6265. This is the document, this RFC 6265, this is the document that describes how to process cookies in browsers. So we need kind of RFC to know how to do it, or vendors need this information. All browsers rely on this RFC, so you can imagine that if we find any weakness in this RFC, then we have the impact of this weakness is, well, it affects all browsers. Would be cool, right, from attacker's point of view. So I want to cover everything, not only web application, that is, this is the first thing that comes to our mind when we think about cookie-related vulnerabilities, but also web browser and also RFC. So you can study it carefully and see if there are any weaknesses. And it turns out that there are weaknesses, so it is really nice. So we'll discuss them. Of course, we've got only 50 minutes, so only selected problems will be discussed, but I'm very happy during coffee breaks or lunch, go deeper and deeper. Okay, so the first subject, secure flag and HSTS. For those who are not very familiar with this, when you may assign flags to a cookie, when a cookie has secure flag set, then this cookie will be only sent over secure channel, so over HTTPS. This is very desired because we don't want our sensitive cookies to be disclosed over insecure HTTP. That's the reason why we have secure flag. So it is really desired. So it's related with confidentiality. We want to protect the confidentiality of our sensitive cookies. What's the problem? When you go and read this RFC 6265, you will see that something strange is out there. What's strange? Keep in mind that secure flag is used to protect the confidentiality of the cookie. Okay, but let's imagine that we can send a request over HTTP. HTTP is insecure. Okay, when this cookie has secure flag, that this cookie will not be appended to this request. So far, so good. But then the response comes over HTTP. This is insecure because HTTP is insecure and plain text. And now very interesting part comes in. You can play with this HTTP response, right? Because this is plain text. There is no security here. And you can embed your set cookie header and overwrite a cookie with secure flag. Can you see the risk here? From insecure HTTP response, you may overwrite a cookie with secure flag, and this cookie with secure flag will be used only in HTTPS secure connections, right? So what's the impact actually? Insecure HTTP response has an impact on HTTPS protected traffic later on, right? Because from insecure HTTP response, we can overwrite a cookie with secure flag that will be used only in HTTPS protected connections. So here is, this is design mistake, the mistake from design point of view. Insecure HTTP should never have impact on secure HTTPS. The core of the problem here is that people focused very much on protecting the confidentiality of the cookie. That's why this flag was introduced. But there is nothing about integrity, right? So we protect confidentiality, but we don't do anything in terms of integrity. So from insecure HTTP, when we might impact secure HTTPS, right? So this is a really significant problem. And it affects all browsers because browsers rely on this RFC 6265. Now, another subject or subtopic, HSTS. There is another way. Well, if you don't, you may ask a question, I don't have secure flag for my cookie. Does it automatically mean that I am not secure? Not necessarily, because there is something, a very powerful technology like HSTS, HTTP Strict Transport Security. This is very powerful because once it is implemented and only one single response header is needed for this purpose, then the whole traffic from the browser will be over HTTPS. Even if you try to manually connect via HTTP to your web application, no, the browser will take care of sending only HTTPS requests. Very good from security point of view. HTTPS enforced on the browser level. So you might have HSTS implemented, and then you don't need secure flag, right? Because actually all requests are going out over secure HTTPS. Looks good, but in practice, it's not so easy, or we have some problems. And the problem is that it works fine, very powerful technology, provided that it is really supported by all major browsers. In case of, for example, Internet Explorer 10, still supported, still updated by Microsoft, used by this number of people, HSTS is not supported, and we need to know about this stuff. Because if this is not supported, then strict transport security is not effective in an Internet Explorer 10. So you need actually secure flag to be protected, right? So in practice, we need to know the details about different browsers, how they process different security features. So in practice, we need to use HSTS and secure flag. In theory, HSTS would be enough, but not all browsers are supporting this. So in case of Internet Explorer, the only thing that will make you protected is secure flag. So in reality, what we should do is use HSTS together with secure flag. Okay. Now, the next topic, importance of regeneration. Here is the story. User logs out, and the attacker is able to learn user's cookie with session ID. Different ways of doing this. User is logged out. So it looks like something completely not dangerous. User is logged out, so what's the reason of learning user's cookie with session ID? What's the point? Different ways, again, XSS, disclosure of an insecure HTTP. So it looks like something strange, something not profitable from attacker's point of view. But what the problem might be, and very often this is a problem in web apps, is that this session ID, or the cookie with the session ID, is not regenerated after successful authentication. In other words, it's still the same. You are in the non-authenticated state. It has some value. Then you log into the app. You are logged in successfully, but it still has the same value. Do you see now why it's risky? Once the attacker, in this scenario, once the attacker is able to read this cookie when user is logged out, it looks like something useless. This cookie is useless, user is not authenticated. But then user becomes authenticated, and the cookie is still the same value. So we learn something useless, and later on, when user authenticates, this is very, very valuable for us, because now we can impersonate a user. And the root cause is the weakness in processing of this cookie, because we should regenerate this cookie. In other words, we should assign a new value to this cookie when we go from non-authenticated state to authenticate state, right? Otherwise, we can always learn something useless when user is logged out and use it later on when user logs in without knowing user's credentials. Very nice. So the consequence is user impersonation. We should not only regenerate cookies with session ID, all cookies with sensitive data, like CSRF token, it might be in a cookie, persistent logging token, or whatever else that is sensitive in a cookie should be regenerated after successful login. Otherwise, we may end up in problems. The next weakness on the web application level, the story. User logs out and cookie with session ID is deleted in user's browser. And we see that we are logged out. I mean users of the web application. What the problem might be? No server-side invalidation. Quite often, the authentication cookie after logging out is deleted in user's browser. But this is not enough. It needs to be invalidated on the server side. Why is it a problem? Why the consequence is user impersonation? Because when you only delete this cookie on the browser level, then the user looks like he is logged out, but in reality, he is not logged out. There was no server-side invalidation, so from the server-side point of view, the user is still logged in. So the user seems to be logged out, but actually he is not logged out. So once you are able to get this cookie when user is logged in via classical XSS, then user may log out many times, but it looks like he is logged out. You can still access his account even if he looks like logged out user, right? So this is it. We need to remember about server-side invalidation. Of course, the assumption is, as I mentioned, that the attacker learned session ID of the user when the user was logged in, right? But this is a question, this is a problem of classical XSS. User is logged in with the cookie with session ID, and then it doesn't matter whether user logs out or not, because on the server side, user is logged in all the time, so we can impersonate the user all the time. Really nice. Now, something different. HTTP only flag. I have already mentioned secure flag. What's the point of HTTP only flag? This is yet another flag that we can assign to a cookie to make cookie processing more secure. When we have this flag set, then JavaScript cannot read a cookie with this flag. What's the logic behind this? The classical XSS attack is like this. We have XSS, so what we want to do is read the authentication cookie of the user via XSS, and then we can easily impersonate the user because that's the only piece of data that we need as an attacker. To mitigate the risk, HTTP only flag was introduced. So then, in case of when this flag is set, then, well, when XSS attack occurs, JavaScript cannot read a cookie with this flag. So from XSS point of view, the most classical one, we cannot read this cookie. So the risk is mitigated. In general, when HTTP only flag is set, then non-HTTP API cannot read a cookie with this flag. So as you can see, it is logical to have this flag implemented. What's the problem? Because during this talk we want to discuss different problems at different levels. It looks fine, but when you go again to this RFC 6265, you will see that this document says about non-HTTPI cannot read a cookie with HTTP only flag. The question is, what about writing permission, right? Because now it mentions reading permissions. But what about writing? Writing permissions or overwriting, right, are not clearly specified in this RFC. And we love it as security guys. Ambiguity is really an enemy of security, or attackers love ambiguity. Because ambiguity very often is related to problems. And this is yet another example showing that this is the case. Writing permissions are not specified. Okay, I cannot read a cookie with this flag. Can I overwrite this cookie? This is the question. Yes, I can do it in Safari 9, the most up-to-date one. Nice, I can overwrite it. The question is what I can do with this stuff. Now, in case of XSS attack, let's build the story and connect different dots, let's say, or different small problems. Try to figure out interesting attack scenario. Now we can, XSS attack occurs, we can overwrite a cookie with session ID. Nice. So this way we can switch a user to attacker's account, right? By overwriting session ID of the user with session ID of the attacker. But what's the point of doing this? Imagine that we've got very popular credit card processing in every single account of the web application, right? Now, if I switch you are a victim, I am an attacker, let's say, I switch you to my account, and if you don't notice that you have been switched, then you enter credit card data to my account. Very profitable, right? So here's the profit. So there is real risk related to this vulnerability, and this vulnerability is like this. We should prevent any kind of overwriting because it's not needed. But there's ambiguity. Safari 8 implements it in a way that it allows this cookie to be overwritten, and here you have the attack scenario, interesting and very real one. Let's continue our process of thinking. What might be yet another consequence of this vulnerability? User impersonation. I am bug hunter. I love connecting simple bugs to have something powerful. I see some of my students from previous days, and they already know about this. We need to connect simple bugs to have something very powerful. And now, okay, let's override session ID of the user. I can do it because I can override cookie with HTTP only flag in Safari 9. Let's override this cookie with another session ID, my session ID, attacker's session ID. Now, do you remember about the problem that I mentioned 5 minutes ago? Lack of regeneration of session ID after successful authentication. Let's connect the dots. Let's override the session ID of the user with session ID of the attacker. If we have yet another vulnerability, session ID of the user does not change after successful authentication. Do you see now what's the risk? The user will be using our session ID. So we changed different vulnerabilities, right? Once again, we override session ID of the user with arbitrary session ID. User is logged out. User logs in. Still the same session ID is being used by the user, but we, attackers, know this session ID, so now we can impersonate the user. Beautiful. So let's change different vulnerabilities to have something very powerful. Okay, domain attribute, the next topic. If you go to the RFC 6265, again, I'm referring to this RFC because this is the foundation. In a set cookie header, when you set cookies, you can specify the domain attribute. This is an information how to handle this cookie. This is about the scope of this cookie, right? And you can read something like this. When domain attribute is not specified, then this cookie should be only sent to the domain from which it originated. So it's really only limited to the domain from which it originated. So we limit the scope, let's say, of this cookie. It looks good. And you can read it in this RFC. In other words, you don't want this cookie to be disclosed to any other subdomain, right? It seems logical. What's the problem? The most up-to-date Internet Explorer 11 will send this cookie additionally to all subdomains of this domain. So let's say you can completely bypass this kind of protection in Internet Explorer 11, or in other words, Internet Explorer 11 completely does not support this stuff, and this is written in this RFC. So even if you are a very smart developer, you very carefully read this RFC because this is the foundation, and you know that it should be processed this way. Sorry, in case of Internet Explorer 11, will be processed in different way, and you may end up in problems. What about attack scenarios? The first one, cross-origin cookie leakage. So just to show you why this is risky and why using Internet Explorer 11 in terms of domain attribute processing might be really not a good idea. Let's assume that we have domain example.com, and on this domain there is a sensitive application like wallet. This is very sensitive application, so we want the cookie, authentication cookie, limit only to the domain example.com, right? This is very logical. So we don't specify domain attribute. When we don't specify domain attribute, we assume that the cookie will be only limited to this domain. Because this is sensitive, we want to protect it as much as possible. But what's interesting is that you might have insensitive subdomain like x.example.com. Insensitive. In practice, it means insensitive means no time spent on security evaluation, pen testing, right? This is reality. This is irrelevant from business point of view. It wasn't tested thoroughly from security point of view. It's good from attacker's point of view because attackers finds XSS on this subdomain. From business point of view, this is insensitive, so I don't care very much. But XSS on this domain can read a cookie without domain attribute on example.com in case of Internet Explorer 11. In all other browsers, this cookie will be only limited to this domain, right? The domain from which it originated. But in case of Internet Explorer, it will be also sent, or it can be accessed from x.example.com, because this cookie will be sent to all subdomains. So XSS on x.example.com can read it. Can you see right now that it's really good to take a look into insensitive domains irrelevant from business point of view and do cross-origin interaction and read very sensitive piece of data. And I'm taking advantage of a vulnerability in Internet Explorer 11 to do this. So from my point of view, I'm bug hunter. It's really nice. Another attack scenario, cookie leakage to externally managed domain. The story here is very similar. Let's assume that there is shared costs hosting company, again, example.com, and for example, /clients. And then you can buy a subdomain, y.example.com. The story is very similar. If you buy this subdomain, you don't need right now any kind of XSS because you own this subdomain, so you have control over JavaScript on this subdomain, so you can read the cookie from the shared hosting sensitive application, right? Because they use the core subdomain example.com. Okay, is it right? Clear? Good. So very similar attack scenario, but something different than you don't need actually XSS in case of shared hosting to do this, because you already own this subdomain and can read a cookie related to the core domain example.com. Okay. The next topic. There is yet another problem in Safari 9. The most up-to-date is that Safari 9 supports so-called comma-separated lists of cookies in set cookie header. What's interesting here is that this is no longer RFC, as you can see. This is no longer RFC 6265. See, RFC 6265 is the most up-to-date one. This one, RFC 2109, is obsoleted. Well, obsoleted. Obsoleted means that any kind of risky features in old obsoleted RFC should no longer be supported in most up-to-date, more secure RFC 6265. Should not be, but the reality is different. That's why I love obsoleted RFCs, some obsoleted standards, and so on and so forth, because when the life goes on, some risky features are still out there. How does it look like, this cookie tampering? Let's assume that you've got something like this, index PHP, and you can normally specify here the parameter lang, like language, and the value DE. In the response, very, very typical scenario for almost every single website is that in response, you will see set cookie with a name lang and value DE, right? Well, you don't see here any kind of cross-site request for the token, so you can remotely change the language of the user in the web application. Well, the impact is very, very low, right? Even if you change it to yet another language, it can be very easily reversed. It does not change anything in the profile of the user, right? This is clear. But what's interesting is keep in mind that this is taken from request and put into the set cookie header in response. In Safari 9, what you can do is you can specify comma-separated list of cookies. So comma, URL encoded space character, another cookie with another value. As a consequence, you can fully remotely tamper with the cookie jar of the user. Fully remotely tamper with the cookie jar of the user. So powerful. So what we can do if we can fully remotely tamper with the cookie jar of the user, we can switch a user to our account. We already know about it. We know why it is interesting, because we can, in a second, learn credit card data of the user. User impersonation is yet another consequence. I have already mentioned lack of session regeneration after successful authentication. So we use cookie tampering to set authentication cookie of the user in user's browser. If there is additional vulnerability, lack of session regeneration, then we can impersonate a user via remote cookie tampering and lack of session regeneration combined together. And yet another attack scenario is XSS via cookie. Many people claim that, well, XSS via cookie is related to local exploitation. No longer. Here you can specify arbitrary cookie with arbitrary value fully remotely. So you fully remotely set arbitrary cookie with your XSS payload. Then the victim visits another page of the web application, and this XSS via cookie is automatically triggered, because we set arbitrary cookie with arbitrary value in a cookie jar of the user fully remotely, and then this is it. This is fully remote XSS via cookie attack. But we used cookie tampering technique to make it working. Great, right? And now my experience is that when many people see something like this, then the status of the bug goes directly from risk low to high, right? Because people see that XSS via cookie is not only local exploitation. So this is an example of more powerful attack with browser-dependent exploitation. So this is when I do bug hunting, I'll always try to know the details about different browsers, details in the browser, and how those problems on the browser level can help me to find more severe bugs. So I'm a big fan of browser-dependent exploitation. Also during my training, I have a couple of very good ideas or very good cases related to browser dependent exploitation, and how it might be very, very helpful to bug hunter or penetration tester. So the next topic, underestimated XSS via cookie. I have already presented to you at the previous slide that we can, in the most up-to-date Safari 9, good market share of this browser, we can remotely launch XSS via cookie. But let's discuss it even further, because this is one of the most underestimated subjects, in my opinion. So what we already know, XSS via cookie is not related to local exploitation. Let me present you remote attack number 1, cross-origin exploitation. Let's assume that we've got very sensitive domain. Oh, here. Very sensitive domain, y.example.com. Very sensitive. It was well tested from security point of view. Then we have also insensitive domain, x.example.com. Well, insensitive in practice means not very well tested from a security point of view. You do pen testing of this web application. It was tested many times by many guys. You only find XSS via cookie. Well, many people will just assign the risk low because it requires local exploitation. But now let's follow my way of thinking. How to launch this attack remotely, right? How to make an impression on your boss or client. Go to insensitive.example.com. The probability of finding XSS here is much greater than here because it's sensitive and it has been many times pen tested. You find XSS on x.example.com. Now, when you have XSS on x.example.com, then what you can do from the XSS point of view is you can set a cookie with a domain attribute example.com. Yes, you can do it. I discussed the problem with domain attribute previously. It was related to domain attribute not specified in set cookie header. But you, if you have XSS here, you can specify a cookie, you can set a cookie with a domain example.com. Yes, you can do it. You are on domain x.example.com, but you can set a cookie related to the core domain. And then it means to the browser, this is how browsers process cookies, when domain attribute is specified, this cookie will be sent to this core domain and all subdomains. Do you see what I'm talking about is, because now I have XSS on insensitive x example.com, I set a cookie with domain attribute example.com. It means that this cookie will be later on sent to all subdomains of this domain, so also to y.example.com. So what I have here, I remotely trigger XSS via cookie on sensitive y example.com, and this is it. Very nice, beautiful combination of different problems. Okay, another remote attack, just to convince you that this is reality. Response splitting. Well, response splitting, the idea behind this vulnerability is like this. We use a special sequence of characters like courage return new line, courage return new line. We split the headers, we escape from the headers to the body, and then we can launch XSS. There's no time to go deeper into this, this attack. But the idea is to split the headers and go into the body, because when we are in the body, then our XSS can be working. And then the story is exactly the same as here. But the triggering point was a bit different. Not a classical XSS, but we can start with from a response splitting. Response splitting leads to XSS, and then the story is exactly the same. Yet another example, cookie tampering Safari 9. I have already discussed it. Just 3 examples. I believe that now you are convinced that yes, XSS via cookie is not local exploitation. We can really do it remotely, so the risk is higher. If you are bug bounty participants, you can definitely get more money for bugs that are remotely exploitable, right? Okay, so what are the conclusions? Because I decided to discuss only selected topics because it's a talk, not a training or something like this. So what we should do, security people, engineers, consultants, researchers, whatever, we should educate development teams. I do believe that this is important. Not only because I am trainer, I love to teach people, but this is the prerequisite. Many security people blame developers that don't know the basics of secure cookie processing or whatever, secure web applications. They don't know the basic of web application security. And this is very wrong, because we should blame ourselves if we don't teach this stuff to the development teams. Because they know a lot of different stuff, a lot of technologies we are not aware of, and it's our responsibility to give this knowledge to them. And if we do it in a good way, then we will have less work actually, and our applications will be much more secure. And this is also the prerequisite of any secure development lifecycle process is training to the people. Then, so the first one was related with web application security vulnerabilities, because almost everyone is developing web apps, right? But browser level, I have presented a couple of problems on the browser level. So what we need to do, we need to cooperate with browser vendors. If we find a vulnerability, we need to cooperate with them to fix this stuff. Because, well, the impact, if there's any vulnerability, then impact is huge, because many people are using the core browsers, right? So it's there are 3, 4, 5 most popular browsers. So any vulnerability in every single browser, well, the impact is huge, because many people are using them. So we need to cooperate with them, they need to cooperate with us. This is the only solution. And then finally, I've presented problems on web app level, on browser level, and on RFC level, the foundation. So we really need to discuss, improve this RFC, because this is the foundation for every single browser, so for everyone. Everyone uses browser many times during the day. This is the foundation, so it needs to be really carefully analyzed, discussed, improved, and so on and so forth. Okay, thank you very much for attention. Of course, I will be, now it's time for question and answers, of course. I will be also available during this lunch break, coffee break, then lunch break, so no worries. I'm very happy to discuss different subjects with people, because this is the idea of being here, right? Not only to give a talk, but to talk to you, answer your questions, and so on and so forth. So if you are afraid now, because it's being recorded and so on and so forth, you have opportunity to talk to me later. No worries. Time for you. Thank you very much.
Thank you, David, Czagan. Questions? Hello. One of your last slides was that you can, from x.example.com, set a cookie to example.com, and then it is valid for y.example.com. Is this now the one of the browser issues, or is this actually the RFC? Because
this one, sorry, this one?
Yeah, I think so.
No, the core of the problem, let me explain again. The core of the problem is that you've got sensitive yexample.com. You have found accesses via cookie here, so many people think that only it can be exploited only locally. So
yeah,
here's the problem.
Is this in the RFC, or is this a browser issue?
Well, if you find accesses via cookie, then this is an issue in the web application, right?
Yeah, that's.
You refer to this one, right?
In every browser, or.
You, I believe that if I get you correctly, you are asking whether if I have accesses on x.example.com, I can set a cookie that will be sent to example.com and all subdomains. And your question is whether this is a problem in a single browser or it works this way, right? Yeah. It works this way in all browsers. So this is the functionality, right? Okay. So I use the functionality or how cookies are processed in all browsers to help myself to exploit this stuff remotely here, okay? So I have a knowledge about cookie processing. I know that when I am on x.example.com, then I can set a cookie when I specify domain attribute with a domain example.com, and then it means that it will be sent to example.com and all subdomains. So I have a vulnerability. I chain this vulnerability with functionality of cookie processing because this works. This cookie setting that I just described 5 seconds ago works this way in all browsers. This is how cookies are processed. So I just using this knowledge to make it working, and this is it. Does it answer your question? Okay, great. Any other questions?
If there are no more questions, enjoy your break and a coffee.
Again, thanks.